Okay, so this is going to be, of course, a projectile again. But instead of shooting from a cliff downwards, we're going to be at the bottom shooting upwards. Okay, so we'll look at a couple different scenarios. So in this first scenario, we're going to have a little cannon over here. All right, and there's a cliff over here like this. And let's say the cliff has a height of 20 meters. All right. Now, when we launch here, our velocity, we're going to launch this thing at 50 meters per second. Okay. And our angle here, theta, is going to be 30 degrees. Okay. And the distance to the cliff, r, is 150 meters. All right. And what I'd like to know then is when this thing fires, okay, where does it end up over here? Okay. Where does it end up on our cliff like this? Okay. So, again, now the first thing that we're going to do is we've got a velocity, we've got an angle. We're going to get our x and y components for our initial velocity. We're just going to do that right off the bat. Okay. And the Vx is going to be go as the cosine, and the Vy will go as the sine. All right. And so what we're going to end up with is, and I'm just going to write the answers down here. V naught x is going to turn out to be 43.3. Oops. 43.3. And let's get another digit on there. It's actually 30. And V naught y turns out to be 25. Okay. Just like that. And we'll put extra 0 on that one too. Okay, so now let's do what we've done the last couple of times, which is we start out with looking at our x and looking at our y information and just kind of see what we have to work with. All right, so V naught x delta t, and then over on my vertical, I've got delta y is V naught y delta t minus a half g delta t squared. Okay, so at this point, we've seen those a lot. These will be on your equation sheet when we get ready for the next celebration of learning. All right, but I promise you're gonna probably have it memorized at that point. Okay. Okay, so we want to know delta y, so we're looking for this value for delta y, but we don't know the time. Okay, we do know our initial vertical position. We know the acceleration, of course. We don't know that time. Okay, let's look over at r. What do we know over here? R, we know how far it's gone, 150 meters, and we know the launch speed, that component is 4330. Okay, so we can use this time, we can use the horizontal information to get our clock to feed our vertical information. So we'll go the other way with it this time. All right. So I can come in here. I can say, whoops. Say my delta t is r over v naught x. So that's going to give me 150 meters per second. Woo! Just kidding. Not 150 meters per second. Just 150 over my v naught x, which was 4330 meters per second. There we go. And once we do that, we're going to get 3.464 seconds. Okay. Did forget to look at my units. That cancels with that. I got seconds in the denominator. So that brings it on up to make it seconds overall. Okay. So There we go. So there's my time, and I can take my time and I can drop it up into this other equation here. Then that's going to give me my delta y. Okay, so V naught y is 25, and that's meters per second. And my time is 3.464 seconds minus a half, 9.81 meters per second squared, onto my time, 3.464 seconds squared. See what's happening with our units. Losing those two leaves me with meters. And then I'm going to have second squared leaves me with meters. Okay, so cool. It all works out just fine. All right, once I plug in my numbers, what I end up getting then is, oh, this is weird, 27.74, okay, or 27.7 if staying with 3 sig figs. So what, so what does that mean? Well, that means we shot clear over the thing. Boom. Okay. So my picture's a little bit messed up. Okay. In fact, we don't hit the wall at all. All right. So if I try to do a little better job with my picture, over here's my cannon. We're firing like this. Boom. Okay. So we went over the cliff. Over the cliff there. Okay. Okay. So that puts us in a position to kind of say, oh, well, that's interesting. So how far, what's our range now? Okay. If we hit the top of that cliff. Okay. All right. So, I'll do that next. I got to pause the video. Okay, so I had to erase a bunch of stuff there. You can see that. So how can we find that now? Well, we're gonna go again. We got to find what's our clock, what's controlling it. All right. So if we look at the x direction, how far it goes depends on time. We don't know the time because we don't know how far it's gone. Okay, so we can't do what we just did. So that means we're back to looking at the vertical information about time. Okay, so in this case, we know that the cliff height is 20 right there. Okay. And so what we'll do is we're going to put in, we've gone uphill. So I put plus 20 meters. And then my Vy component is still 25. My delta T, I don't know. Oops, sorry, I forgot my units thing. 25 meters per second. Don't know my time, minus a half, 9.81 meters per second squared. Delta T squared, all right. This is going to be seconds, so that's going to cancel in there. This is going to be seconds squared. It's going to cancel there. Okay, so meters and meters, everything checks out. All right, so now I got a quadratic equation to solve again. Okay, so I'm going to get my delta T here. And when I run my numbers on this using my calculator, I get two numbers again, 0.9938 and 4.103 seconds on those. Okay. All right, now we got two numbers. What do those numbers mean? Well, actually, it turns out it's kind of cool. This first number here, that represents the first time we went above the 20 meter mark. Okay, so it took slightly under, a hair under 1 second to get 20 meters in the first place up in the air. And then it took a little bit longer, and our second number here is over there when we finally are up on top and we're coming back down through the 20 meter mark again. Okay, so for our purposes, we want to use that number 4.103. Okay, and So if we plug in some numbers here, R V naught X is still 4330. And our delta T, we'll use the 4.103. Quick units check. Boom, boom. Okay, good. We got meters. And R is, with sig figs, 178 meters. It's actually like 177.7 stuff. Okay, so 178. All right. There we go. Okay. So those are the major things that you need to know how to do with the projectile problem. You need to figure out, be able to figure out how far has it gone under a lot of different conditions. Shooting uphill, shooting downhill. Okay. How fast is it going when it lands? What's the angle when it lands? All that sort. Those are the most basic things, okay? Then there are other parts that are a little more, let's say, interesting, okay? That you're going to have to kind of apply your brain and, and think pretty hard about, and you can work it out, okay? But these are the basic things, and you need to know these basic things before you can do anything more interesting, okay? All right, there you go.